Welcome back to Writing Games with C# and XNA. I'm your host, Rob Miles. I've been your host now for quite a while. This is the last section in this chunk of the course. After this, you can do stuff if you want. I'm putting some labs up and some bits and pieces for you to play with to learn how to write your own programs and explore the ideas we've been playing with. I mean, the thing you ought to bear in mind is that we are actually learning stuff. Surprise, surprise. We've made a MoodLight of sorts. We've actually played around with this, and in this section we're going to make a proper MoodLight, one you could show people and maybe not impress them, but at least make them think that perhaps you haven't wasted too much of your life trying to get it to work. So the idea here is that we're going to move in and actually make a MoodLight that works, a thing you can be proud of, a thing you can show mum. Okay? Now, we actually know quite a bit. Yeah, there's stuff I know. I can't remember. There must be stuff I know. I'll have to go and look now. We know that in XNA we actually store colours as numbers. Numbers that give us the intensity of the red, green and blue values. And the bigger the number, the brighter the colour. We also know that if the box that the number is held in overflows, in other words, put a number bigger than 255 in there, it goes back round to zero, like a card does when you go over the end of the milometer limit. And what that means is that the colour intensity goes back down to zero as well. We also know that in XNA the update and draw methods that make things happen in the game and draw the game on the screen, they are called around 60 times a second, and we've actually fiddled around with statements in the update and draw methods to get this slowly building lamp, which gives us the first part of our MoodLight. We started off with a need for a range of different colours. At the moment we've got a thing that just fades up and then stops, but that's a start, and now we're going to finish things off. Excuse me a moment. And so the idea now is we're going to move on and actually nail this, to use a technical term used by carpenters, I guess. So if we go and have a look at where we came in, which is where we left last time, I'll just make some windows dance about in a vaguely confusing manner. Find my way to the desktop. Ah, hello, there you are. Click on here and go into this. Now, this is where we finished last time. Okay, this is the game. There's my values that give me the amount of red, the amount of green and the amount of blue. At the start of the game there's 0, and then if we drill down here to the update method, we make a colour based on the amount of red, the amount of green and the amount of blue, and we're going to use that to draw with in a minute or two. And then we say, okay, if we haven't reached 255 yet, get bigger. So if the red intensity is less than 255, make it larger. That kind of caps it. That means that if it hits 255, we aren't going to make it any larger than that. So what happens, and I'll run this program just to prove it in a second, is that that value there will get bigger and bigger and bigger and bigger and bigger, hit 255, at which point this condition will no longer be true. So this statement, which is controlled by the condition, won't be performed. So the idea here is that when you hit 255 you stop. We do the same thing for the green and the blue, and so the idea is that our light will fade smoothly up from black to white and then stop. And the background color we invented here is actually used in the draw method to clear the screen. So if you got all that, then what I'm about to do will make perfect sense. If you haven't, then wind me back or something. That might sound actually like kill them all, if you play it backwards, but maybe not. Wind me back and have another look at that until it actually makes sense. The rest of you can just watch this. So here we go. It gets brighter and brighter and brighter and brighter and brighter and then stops. As a little experiment, I like experiments, what do you think would happen if I change these numbers to, rather than 255, let's go to 80 on each of these. Now anyone that thinks they know what can happen, put your hand up. Oh yeah, you at the back? Yeah, okay, yeah. That's right. The guy at the back's very good. He knows, or has just told me, that if I run the program now, it gets brighter and brighter and brighter and stops at a fairly dirty grey, because the cutoff, it's stopping updating earlier on. I mean, I can have fun with this. If I make that 180 and that one say 255, and this one here, I don't know, 42. I don't know what will happen now, but we'll see. If I now run the program, when red gets to 80 it'll stop, when the green reaches 255 it'll stop, and when the blue hits 42 it'll be kind of like a lot of green, bit of red and some blue, which gives us the colour kind of green. Not full green, but green with red and yellowy bits as well. So we can make whatever colour we like here and make a lamp that fades up to that value, which is kind of sweet. So if you've got all that, then you're now in a position to move on to the next slide. The next slide, in that we now have a fading up thing which we can control, and we can even set the colour we want to arrive at, which is kind of sweet. But I don't want to do that. You can play with that if you like, I don't really mind. I want the light to fade up and then fade down again. I want a smooth sort of, gets brighter and brighter and then darker and darker and then brighter and brighter. I'm moving my hands up and down to show how I want it to behave, which in a screencast doesn't add a lot of value, to be honest, but just imagine me going brighter and brighter and brighter and then darker and darker and darker, and that's what I want. So we'll have to make the program do that, and to do that we have to add some more code. If you're fading up, you get brighter. If you're fading down, you get dimmer. So effectively we're going to have two different behaviors in our update method, depending on whether we're getting bigger or getting smaller. If you think about it, that's how you make it work. If you've ever seen a glowing light that pulses slowly in a video game, this is the kind of thing that the video game program is doing to get that effect. It's changing that color over time, and it has to know, our program has to know, whether it's getting brighter at the moment or darker at the moment. So we can't rely on the stuff in the computer just figuring out what we want and then doing it. We have to put all the stuff down. Programming is a great way to spend your time. It's very interesting. It's actually intellectually quite challenging. So surprising I can do it at all, really. But we'll move on from that. We have to have a way of holding the state of our program. And state is something about the program. At any given instant in time, the light's either getting brighter or getting darker. Okay, so at any given instance, something inside the program has to know this. Okay, we can't rely on the computer being clever enough to figure out what we want. We have to put in the itty bitty annoying tiny statements to get this behavior, and the way we do that is by adding another variable. Okay, we remember things by tying knots in handkerchiefs, putting bows around our right index finger, writing stuff in lists, doing all kinds of things to try and inventing limericks and things to try and remember. That's how human beings do it. Okay, computers don't do that. They have these things called variables. These are boxes with names in. We've used three already. One's called red intensity, one's called green intensity, and one's called blue intensity, and they hold the amount of red, green and blue in the program. Okay, what we have to do now is add a fourth variable that basically says at the moment you're counting up, or at the moment you're counting down. Okay, it has two possible state values, going up or going down. Okay, and that's what we have to add to our program to actually make it work. We have a special type in C# specifically for this, which is really nice. It's called the bool type, named after a Frenchman who invented Boolean algebra. I can't remember his first name. It might have been Gustave or some other French name, and he invented this technology which basically worked on logic. Things are either true or false, and he invented this stuff. It was quite a while back now, but the name stuck, and so now in C# a variable that can hold either true or false is called a bool type. Okay, numbers I can put in some kinds of variables, others are designed specifically for particular jobs, and in the case of the bool type it's good for holding true or false. So I'm going to make a variable, I'm going to call it counting up, and if it's true we're counting up, and if it's false we're not counting up, we're counting down. Okay, so this holds the state of our flashing, of our pulsing light. Okay, it's a new type. We haven't seen it before. We've seen byte before. Byte can hold numbers up to 255. Bool can hold values true or false. In fact, if you look inside a computer and have the lid off and scrape the chips about a bit and take a look really inside at how the gates and things actually work, the entire computer works on the basis of ons and offs. We've seen this before when we looked at binary bits. So basically a bool type takes our program right back to brass tacks. It's really the kind of things that computers are designed to work on at a hardware level. So we're going to use a bool type. It will hold the state of our flashing light, and we're going to call it counting up, which means if I'm true, I'm counting up. Okay, so here we go. The little shaded area on the screen shows you my new variable. It's called counting up. The convention in C# is I say that's the type of the box that I want. This is the name of the box I'd like to use, and I can set it to a value if I'd like to get it started. So this one holds the background color we're going to use in draw. These three folks here hold the intensity of red, green and blue colors, and this thing here is true if we're counting up and false if we're counting down. Now at the start everything's dark. These things are all naught. So I must count up at the start. Okay, so I set this thing equal to true, so when I start counting up it'll get bigger and bigger and bigger, and the update method will look at this variable, look at the value in counting up to decide whether to count up or count down. So let's have a look at some more code. Okay, now this is the kind of thing we can do. I can test the value of a bool variable directly in a condition. Okay, so the rule is now, the bool rule, said the poet who didn't know it, sorry about that, mild digression, is if this thing is true, we'll do the statement here. And something else about C# that's worth knowing, conditions can have an else bit, which is something you do if the condition is false. My mother used to do this. If you behave yourself, you can have a sweetie, else I'll make you do the washing up. Okay, so I behaved myself a lot and I got lots of sweeties. I was ever such an adorable child, completely adorable, but I digress. The computer works in the same way as my mum, in that if condition, we do something else, we do something else. So here, if we're counting up, we do the counting up bit. If we're counting down, we do the counting down bit. These green bits are what's called comments, and they're kind of notes for me to remember what that bit of the program's supposed to do. They come out as green in the editor, we'll see in a minute or two, and they're not for the computer to use particularly, they're just for Robert so that he can make sense of his program. Okay, so ifs can make decisions, we've seen that. They can also have an else bit, which is the bit that marks a statement which is performed if the condition fails. Okay, so if we're counting up, we do that bit, else we do that bit. Simple, you see, no worries at all there, all very nice. Okay, now snag is, I might want to do more than one thing if I'm counting up. If I'm counting up, I have to update the colors, and then if the colors have reached the limit, I have to count back down again. Okay, so if the colors get too bright, I have to go, okay, we're not getting brighter anymore, we're getting darker now. And so I have to make more than one statement controlled by my condition. I could have three separate conditions if I wanted. That would be a bit daft. And wouldn't work terribly well. What I want is a way of blocking or lumping together a bunch of statements which are controlled by a single test. C# has a thing just for this. It's called the block. This is my kind of clip art humour. Those are blocks as well, but they aren't kind of the blocks we're talking about here. That's just meant to be funny, and I can hear you all out there laughing even as I speak. But anywho, I make a block of statements which are controlled by the test, and this is how I do it. Okay, if I'm counting up, we have a curly bracket that says this is the start of the block. And then I have all the statements which are in that block and need to be obeyed if the condition is true. If I'm counting up, red gets bigger, green gets bigger, blue gets bigger. If the red value has hit 255, I say I'm going to make counting up false because I don't want to count up anymore. So next time update gets called, that condition will fail, so we do the else bit, we do the counting down. Now this reminds me of those mechanical sort of like mousetrappy type things where you've got little balls in wheels and sort of contraptions that do one thing and then something else, all chained together and sort of mechanically designed. Programming is really a lot like that, in that what you're doing is getting a bunch of statements tied together to get the program to behave in a particular way. And so I've made a little machine here. it's called a state machine if you want to know what it's called, which is going to flip between counting up and counting down, because I'll have a test in the other bit down here which will check to see when these values hit 0, because when they hit 0 they have to start going back the other way, so counting up has to become true at that point. But in terms of blocks, use a curly bracket like this, open curly bracket there, bunch of statements, close curly bracket there, and then these statements here are all controlled by that single condition. One of the golden rules here, my favourite golden rule is the man who's got the gold makes the rules. That's kind of relevant here, and I want to move on. The actual situation here is that you must have as many of these closed things as you have open things, otherwise the compiler gets very cross, and you you must make sure it makes sense, he said badly, in that you must make sure that you have the statements in here that you want to have controlled by this condition. Now the way the robot does it, and lots of programmers do the same thing, is to use indenting. So these statements here are quite obviously stuck inside these curly brackets and are controlled by that condition. Okay, so curly brackets are how you do it. Be careful how you use them, get the layout right, and everything will work fine. Okay, so yeah, that bit there updates the intensity. We've seen that code before. This bit here flips the test, flips the state of the light, so it performs the test and makes it get darker if it's got as bright as it can be. Okay, so you got all that. We can now move on and take a look at this little magical thing here, which is a way I can test to see if two things are equal. Now we've seen greater than, we've seen things like that. Equals is a little bit irritating in that it sort of doesn't quite look like it should be a single action, but it's what you use in C# to perform a test. You see here I've got 1 equals all by its little lonesome self, and what 1 equals means is take this value and shove it in there. This is the assignment that goes into we've talked about before. This thing is a test. The two things are different. The compiler can tell them apart. The compiler will drop a safe on your head or do something very sort of Acme type Roadrunner type on you if it detects the wrong thing. So do bear that in mind and try and get it right, because otherwise your program won't compile and you'll spend ages wondering why when it looks perfectly okay to you. But back in the in sort of the context of this program, that there is a test to see if that value is that value, and if the two things are equal, then hey, we have a condition which fires and sets the value of counting up to false in this statement here. Now I've put ifs inside ifs. That's perfectly okay. Everything lines up absolutely fine. In fact, it all works perfectly peachy, as we will see in a minute or two. Okay, so we're going to have a little go now at the code to sort of write the going down bit. So what do you think it should do? How would this work? I'll just take my way along to the program, and here's the code that takes me up. Add more red, add more green, add more blue. If they hit the limit, then we start counting down. Else, if you think about it, you can get a long way by just looking at the pattern in the program that you've got and figuring out how you're going to actually change that to get the behavior going the other way. And so what I've done here is made red get smaller, made green get smaller, made blue get smaller, and if red has hit 0, we start counting up again. And so if you look at this sort of, it's kind of symmetric. This one makes everything get bigger and then starts counting if we've hit the top. This thing makes everything smaller and starts counting up if we've hit the bottom, as it were. So in a nutshell, this is how you do it. Just look at the code. The code will tell you, and think about what you want to do. When it's got too bright, it must start getting darker. When it's got too dark, it must start getting brighter again. And so if you hold in your mind what it is your code's trying to do, then these statements start to make a lot of sense. And if we run the program, we'll find that lo and behold, they actually work. So we now have a smoothly pulsing light, which is sort of going slowly brighter and darker, and that will keep on doing that behavior now pretty much forever. If we want to make it pulse faster, well, there are ways we can do that by adding more than just one each time to the values of the red or the green or the blue. If we wanted to go between light grey and dark grey, we can change the limits that cause the direction of change to actually kick in. So there you go, we now have our nicely pulsing MoodLight, and the bit that makes it go, the bit that makes it work, is this little piece of code here. So if you're looking for where the intelligence of our program is, the thinking bit if you like, it's actually this little piece I've just made go blue. I've just lit up because this is the stuff that does the work. Everything else is just wrapped around this to allow that bit of code to do its stuff. This happens a lot with programs. The bit that does the work is tiny, and then there's huge amounts of stuff wrapped around it to set everything up and give it a place to live and behave in the way it should. Okay, so I'm quite pleased with that. That kind of seems to work, and now we can drop back to our presentation and award ourselves a pat on the back, which reminds me of an awful joke involving cows, which I can't really say because it's not that funny. So we've got a pulsing light now, which is really good. We can add variables to game programs that hold the state. We can use a state variable to decide what to do. And by modifying this state value, we can control how the game behaves. You see this a lot in games. Okay, everything in your game has a state. Enemies will have a state of healthy, wounded, or dead. Missiles will have a state of fired, in the air, collided with whatever, exploded. Everything in a game has a state. You can look around a particular game and try and work out what states are being used to manage all the various things in there, if you like. But the whole basis of making games work is managing the state. We only have one state in our MoodLight. Are you getting brighter? Are you getting darker? But you can see that that's exactly what you need to make it work. So here we go. Last little bit. True or false? Here we go. A Boolean variable can only hold the values 0 and 1. One of my nasty questions. Sorry about this, people. That's actually rubbish because it's true and false. Some programming languages say 0 and 1, but C# does not. It actually has the word true and the word false, and they mean exactly what it says on the tin. Okay. Next one. The state of a game program must change each time update is called. What do we think? Well, actually, I would say that was false because it doesn't always change state. Our MoodLight will change when red gets too bright or too dark, but in the 250 odd update calls between those two conditions, the state of the program remains pretty much the same. So as far as I'm concerned, I'm going to call that red. We control in our program when the game changes state. Your copy of whatever game you're playing will decide at which point you've shot the enemy spaceship enough times to make it explode, and so now I think you can see how that would work. We just keep on counting how many missiles have hit us until finally we go, oh, more than 203, time to explode, and then it plays the explode animation, its state changes to dead, and the game moves on to the next thing. So, I mean, we control in our logic how we want the state of the game to change. A block of C# code can hold another block. Yes, it can. We've actually seen this in that the update method has a body, which is a block of code, and we put an if statement in there which can hit another block, and the two, it's called nesting. It's not just one programming for the birds. It's called nesting, and it just means you can do this as much as you like as long as the brackets line up, which brings us nicely to the final question, which you probably all know the answer to now. The number of open bracket and close bracket characters in a C# program must be the same. Oh yes. Get that wrong and all kinds of bad karma come whistling down and make your life very miserable and unpleasant. So yes, you must. That's a must be. You must do that. Otherwise your program will not compile. The compiler will go, ooh, too many of opens or too many of closes, and you'll have to go and look for all the things. If it's indented, it'll be much easier to find things. Do bear that in mind. Okay, so What I want to do now, though, is get even fancier. Oh, I want to have mood lights that change, ever-changing colours, like the ones you can buy that go between red and pink and green and purple, rather than just between black and white. Turns out this is really easy. In fact, it's so easy that I'm going to get you to do it. You're going to make this version of the program because the person we hired to do this nipped out for a cup of coffee and we haven't seen him since. If you want to have a go at this, and I'd love you to have a go and let me know how you get on, go to verysillygames.com/screencasts, the link on the screen, and on there you'll find some directories, some bits and bobs, the source files and the lab sheet that tells you what to do. And once you've made this, you will have something that I guarantee, personal guarantee of Rob Miles, well worth the paper it's not written on. You'll have something which will mildly impress someone, and what's more, you'll know exactly how it works, which is the really interesting bit. So please do that. Please go and have a look. Please have fun. Please have a play. If you have any problems, then there's an email link on there as well to tell me how you're getting on, and see what happens when you make a game where the lights go up and down. Okay? So thank you very much for listening and watching. If you didn't, well, no thanks at all to you. I'll be back next time. We're going into the second chapter. We get to play with the gamepad. Ooh, yes we do. But that's next time. Bye-bye.